Open Staxx Chapter 2 Psychological Research Continued. We should be informed consumers of the information made available to us because decisions based on this information have significant consequences. One such consequence can be seen in politics and public policy. Imagine that you have been elected as the governor of your state. One of your responsibilities is to manage the state budget and determine how to best spend your constituents' tax dollars. As a new governor, you need to decide whether to continue funding the DARE, Drug Abuse Resistance Education Program in public schools. This program typically involves police officers coming into the classroom to educate students about the dangers of becoming involved with alcohol and other drugs. According to the DARE website, this program has been very popular since its inception in 1983, and it is currently operating in 75% of school districts in the U.S. and in more than 40 countries worldwide. Sounds like an easy decision, right? However, on closer review, you discover that the vast majority of research into this program consistently suggests that participation has little, if any, effect on whether or not someone uses alcohol or other drugs. If you are committed to being a good steward of taxpayer money, will you fund this particular program, or will you try to find another program that research has consistently demonstrated to be effective? Ultimately, it is not just politicians who can benefit from using research and guiding their decision. We all might look to research from time to time when making decisions in our lives. Imagine you just found out that a close friend has breast cancer, or that one of your younger relatives has recently been diagnosed with autism. In either case, you want to know which treatment options are most successful with the fewest side effects. How would you find that out? You would probably talk with your doctor and personally review the research that has been done on various treatment options, always with a critical eye to ensure that you are as informed as possible. In the end, research is what makes the difference between facts and opinions. Facts are observable realities, and opinions are personal judgments, conclusions, or attitudes that may or may not be accurate. In the scientific community, facts can be established only using evidence collected through empirical research. The process of scientific research. Scientific knowledge is advanced through a process known as the scientific method. Basically, ideas in the form of theories and hypotheses are tested against the real world in the form of empirical observations, and those empirical observations lead to more ideas that are tested against the real world, and so on. In this sense, the scientific process is circular. The types of reasoning within the circle are called deductive and inductive. In deductive reasoning, ideas are tested against the empirical world. In inductive reasoning, empirical observations lead to new ideas. These processes are inseparable, like inhaling and exhaling, but different research approaches places different emphasis on the deductive and inductive aspects. In the scientific context, deductive reasoning begins with a generalization, one hypothesis that is then used to reach logical conclusions about the real world. If the hypothesis is correct, then the logical conclusion reached through deductive reasoning should also be correct. A deductive reasoning argument might go something like this. All living things require energy to survive. This would be your hypothesis. Ducks are living things. Therefore, ducks require energy to survive. Logical conclusion. In this example, the hypothesis is correct. Therefore, the conclusion is correct as well. Sometimes, however, an incorrect hypothesis may lead to a logical but incorrect conclusion. Consider this argument. All ducks are born with the ability to see. Quackers is a duck. Therefore, Quackers was born with the ability to see. Scientists use deductive reasoning to empirically test their hypothesis. Returning to the example of ducks, researchers might design a study to test the hypothesis that if all living things require energy to survive, then ducks will be found to require energy to survive. Deductive reasoning starts with a generalization that is tested against real-world observations. However, inductive reasoning moves in the opposite direction. Inductive reasoning uses empirical observation to construct broad generalization. Unlike deductive reasoning, conclusions drawn from inductive reasoning may or may not be correct, regardless of the observation on which they are based. For instance, you may notice that your favorite fruits, apples, bananas, and oranges, all grow on trees. Therefore, you assume that all fruits must grow on trees. This would be an example of inductive reasoning, and clearly, the existence of strawberries, blueberries, and kiwis demonstrate that this generalization is not correct, despite it being based on a number of direct observations. Scientists use inductive reasoning to formulate theories, which in turn generate hypotheses that are tested with deductive reasoning. In the end, science involves both deductive and inductive processes. For example, case studies which you will read about in the next section are heavily weighted on the side of empirical observations. Thus, case studies are closely associated with inductive processes, as researchers gather massive amounts of observations and seek interesting patterns, new ideas in the data. Experimental research, on the other hand, puts great emphasis on deductive reasoning. We've stated that theories and hypotheses are ideas, but what sort of ideas are they exactly? A theory is a well-developed set of ideas that propose an explanation for observed phenomena. Theories are repeatedly checked against the world, but they tend to be too complex to be tested all at once. Instead, researchers create hypotheses to test specific aspects of a theory. A hypothesis is a testable prediction about how the world will behave if our idea is correct, and it is often worded as an if-then statement. If I study all night, I will get a passing grade on the test. The hypothesis is extremely important because it bridges the gap between the realm of ideas and the real world. As specific hypotheses are tested, theories are modified and refined to reflect and incorporate the results of these tests. To see how this process works, let's consider a specific theory and a hypothesis that might be generated from that theory. As you'll learn in a later chapter, the James Lange theory of emotion asserts that emotional experience relies on the psychological arousal associated with the emotional state. If you walked out of your home and discovered a very aggressive snake waiting at your doorstep, your heart would begin to race and your stomach churn. According to the James Lange theory, these psychological changes would result in you feeling of fear. A hypothesis that could be derived from this theory might be that a person who is unaware of the psychological arousals that the sight of the snake elicits will not feel fear. The scientific hypothesis is also falsifiable, or capable of being shown to be incorrect. Recall from the introductory chapter that Sigmund Freud had lots of interesting ideas to explain various human behaviors. However, a major criticism of Freud's theory is that many of his ideas are not falsifiable. For example, it is impossible to imagine empirical observations that would disprove the existence of the ID, the ego, and the superego, the three elements of personality described in Freud's theory. Despite this, Freud's theories are widely taught in the introductory psychology texts because of their historical significance for personality, psychology, and psychotherapy. And these remain the roots of all modern forms of therapy. In contrast, the James Lange theory does not generate falsifiable hypotheses, such as the one described above. Some individuals who suffer significant injuries to their spinal columns are unable to feel the bodily changes that often accompany emotional experiences. Therefore, we could test the hypothesis by determining how emotional experiences differ between individuals who have the ability to detect these changes in their psychological arousal and those who do not. In fact, this research has been conducted, and while the emotional experience of people deprived of an awareness of their psychological arousal may be less intense, they still experience emotion. Scientific research dependence on falsifiability allows for great confidence in the information that it produces. Typically, by the time information is accepted by the scientific community, it has been tested repeatedly.